Notes 1.4, this time on midpoint and perpendicular bisector. We begin with midpoint. Midpoint divides a segment into two congruent segments. So when you look at the picture given, segment BM has point A in the middle, and you see tick marks here and here. So without telling you that segments are congruent, we're showing you segments are congruent with those tick marks. So the question is, why is A the midpoint of BM? And that's because segment BA is congruent to segment AM. That's how we know A is the midpoint. So can a line or ray have a midpoint? The answer is no, because they go on forever. You would not have congruent segments to show in the case of a line or ray. In number 2, we're being told that B is the midpoint of AC. Would you mark the diagram right away, please? Always do that. We are given some algebra for AB. So AB is 6x squared plus 6x plus 17. And then CB is 2x squared minus 10x plus 2. Since AB, I'll write that down. Since AB is congruent to CB, then you could say 6x squared plus 6x plus 17 equals 2x squared minus 10x plus 2. So I will subtract 2x from both sides and add 10x and minus 2 from both sides, and I'll get the quadratic 4x squared plus 16x plus 15 equals 0. That's a quadratic which will factor into two binomials. They are 2x plus 3 and 2x plus 5. So I'm going to take each of those and solve for x. So if 2x plus 3 equals 0, then x is negative 3 halves. And if 2x plus 5 were to equal 0, then x would equal negative 5 halves. And so to find AC, which is the entire segment, I need to take one of the halves of AC and multiply it by 2. So if I take 6x squared plus 6x plus 17 and I times it by 2, then I would get the length of AC, or I could just add them together. I could add both halves together if I wanted to. So AC equals this, and you could set it up those other ways if you prefer. So I'm going to do 6 times negative 3 halves plus 6 times negative 3 halves plus 17. Now I forgot to put the squared here, so there it is. And I'll put that into my graphing calculator. So when I have negative 3 halves substituted in for x, I get a total of 43. So the length of the segment would be 43 if x were negative 3 halves. However, the value of x could be negative 5 halves. So I'll do that again. AC is 2 times 6 times negative 5 halves squared plus 6 times negative 5 halves plus 17. And using the graphing calculator, I would get 79 as the length of the segment. So there's two possible answers for this question. In number 3, A is the midpoint of SM. Please mark the diagram right away. You could do double tick marks if you wish. So that's another way. SA is x plus 5. And this time we get the whole segment SM is 5x minus 26. So there's some way to set up an equation with these two pieces of algebra. You have choices. Since SA is x plus 5, then AM is also x plus 5. So you could add those x plus 5's together and set it equal to 5x minus 26. Or you could do 2 times x plus 5 equals 5x minus 26. So I'll solve for x. So with x equal to 12, I can find AM. AM is x plus 5, and x is 12, so 12 plus 5 is 17. In number 4, I'm asking you to mark the diagram again. So you could use a single tick mark or a double tick mark, or you could use like zeros or little O's. You can make that mark if you wish. Another mark for congruent segments could be like a squiggly like this. So those are some options of how to mark the diagram. And I'm asking you, this is a different kind of question, I'm asking you for the congruence statement here. So congruence statement, what does that mean? Well, what's congruent in the picture? Can you see what's congruent in the picture? Right here, this segment is congruent to this segment. So I literally want you to write that to practice it. Segment LO is congruent to segment OV. Okay, I'm going to ask you that question so that you practice writing congruent statements. So expect those in homework and on my assessments. The next problem has to do with a perpendicular bisector. So I'm going to go back to the top and read about perpendicular bisector. Now, there are two players here, the perpendicular bisector, and then there's the segment. So the perpendicular bisector of a segment is a line that's perpendicular to the segment, and it divides a segment into two congruent segments. So in the picture here, I can identify right away where the congruence is. Do you see that EX is congruent to XA? So that's the segment being bisected. So I'm going to just say that's the segment being bisected. And if that's the segment being bisected, what's the line doing the bisecting? Well, the line is TS. This is the bisector, cutting the segment in half. And they're actually telling us it's the perpendicular bisector. So right away, you need to add in the marking for perpendicular. Remember, perpendicular lines make right angles. So you're going to put that little right angle box in the corner there. So we'll answer this question. What must be true about angle TXA? So you can say angle TXA is a right angle. And since it's a right angle, you can say the measure of angle TXA is 90 degrees. So let's see what number 5 was asking. Number 5 wants me to mark the diagram and then write the congruence statement. Okay, so we don't have to do any algebra. Which segment is being bisected? The given information says that CE is the perpendicular bisector of HW. So the thing being bisected is HW. So go over to the diagram and choose your marking. I'm going to go squiggly line on this. Squiggly. So the congruence statement then is HY is congruent to WY. Notice how the bisector is not drawn like a line. So that's okay. Segment CE is part of a line CE. So CE, the segment, is like a subset of the line CE. Also, get used to putting the marking there for a right angle. That tells me or tells yourself that it's perpendicular, or you know that it's perpendicular. Okay, number 6. IA is the perpendicular bisector of FL. So FL is being bisected here. So let's get that marked on the diagram. And then I'm going to put the algebra in. They're telling me Fn is 3x squared minus 15x. And then angle INL. Well, I know INL is a right angle because we had a perpendicular bisector there. So INL is a right angle, and its measure, the algebra for it, is 14x minus 8. So that means I could find out what x is right now because I know that angle is a 90-degree angle. So 14x minus 8 equals 90. Let's solve for x. Okay, x is 7, and I need to find the length of FL. Okay, I don't have algebra for all of FL, but I have algebra for half of it. Notice how Fn is this algebra 3x squared. So I'm going to double that. So write 2 times 3x squared minus 15x. So that's the algebra for the entire FL. Now I just need to put my 7 in there. So 2 parentheses 3 times 7 squared minus 15 times 7. You can just use the graphing calculator and you should get 84. Please practice with your graphing calculator and put the parentheses in there also. Number 7. S is the midpoint of AI. Okay, that they didn't give us a perpendicular bisector there. They just said that S is the midpoint. So let's mark S as the midpoint. Okay, that's telling you that S is the midpoint by marking the two segments congruent. AS is 3x minus 5. IS is x plus 15. This is good. Did you notice both of those segments are marked congruent? So we have a way to find x right now. So I'm going to say 3x minus 5 equals x plus 15, and I'm going to solve for x right now. So I'm going to subtract x, add 5, x is 10. Okay, what am I going to do with that? Let's see. It says the angle ISC, so that's this angle here, ISC, has algebra measure of 8x plus 12. Is BC the perpendicular bisector of AI? So what that means is angle ISC a right angle? Because if ISC is a right angle, then I know I have a 90-degree measure there. Then I can say those two segments or two lines are perpendicular to each other. So let's check. We're going to write down the measure of angle ISC is this algebra, 8x plus 12. Then we're going to substitute in the 10 that we got for x. 8 times 10 plus 12. On the calculator, I end up getting 92 for the angle. So the answer to this question is no, because the measure of the angle must be 90 degrees if BC is perpendicular to AI. In this part of the notes, we're giving you a segment that's already drawn on a coordinate plane, and we have to find the midpoint of the segment. So you could do this a couple of ways. You already learned partitioning. So if I look down here at the change in x of 6, and if we're finding a midpoint, we want half of that. Half of 6 is 3. And then remember, we were taking the coordinates for A and adding 3 to the x coordinate. So the coordinates of A, you have to look at the actual graph here, is -2, 5. So -2, 5. And if I add 3 to negative 2, I get positive 1. Now you really don't have to do more adding, because if you go to positive 1 on the x-axis and go work your way up to the segment, that's the point with a x-coordinate of 1 that's on the segment. So the point is 1, 2. The midpoint is 1, 2. So that's the partitioning approach. In number 2, the change in x from negative 3 to positive 7 is a change of 10. And half of 10 is 5. So I just need to add 5 to the x-coordinate of A. A is at negative 3, negative 1. So I'm going to add 5 to negative 3, and I'll get positive 2. So go to positive 2 on the segment is actually at 2, 0. It ended up being right on the axis. Okay, you could probably do these quicker, but because I'm showing it to you, I have to write it out. You probably don't need to write all this out anymore. A is at negative 2 and B is at 5, and the change from negative 2 to 5 is 7. And half of 7, you could say, is 7 halves or 3.5. I'm going to leave it as 7 halves. It's up to you. It doesn't matter to me which you prefer. A is the point negative 2, negative 4, and I'm going to add 7 halves, which is like 3.5, so I end up with like 1.5. So it'll be 3 halves for the x-coordinate of the midpoint, and 3 halves is right here, so that's at negative 1/2. So the midpoint is at 3 halves, negative 1/2. And I don't know if you notice, but I'm literally taking the x-coordinates, adding them up. So negative 3, there's like a distance of 3 to the left and a distance of 3 to the right. So the change in x is 6. Half of that is 3. I keep taking half of the change in x, and that's getting me my new x-coordinate. So I have to move 3 units. Now this is point B on the left, so I'm going to look at point B's coordinates, negative 3, 3. It doesn't matter that I'm starting at B because I'm going halfway down the segment. So the direction I go in doesn't matter because I'm going halfway every time. If I add 3 to negative 3, I get 0. So the midpoint is at 0, 1/2. Here's a formula to help you find the midpoint if you prefer a formula over the partitioning. Take the x-coordinates and add them and divide by 2. Take the y-coordinates and add them and divide by 2. That'll get you the midpoint, especially when you don't have a picture handed to you. So number 6, I don't have a picture, but I know I can take the midpoint by averaging the x's and averaging the y's. So I'm going to do negative 3 plus 9, because those are the x-coordinates, and I'll divide by 2 after I add them. And then the y-coordinates are 6 and 8. So add 6 and 8 and then divide by 2. So the midpoint here is going to be negative 3 plus 9 is 6, divided by 2 is 3. And then 6 plus 8 is 14, divided by 2 is 7. So the midpoint is 3, 7. I'll just use the letter M for midpoint. The midpoint will be negative 5 plus negative 9 divided by 2, and then 10 plus 18 divided by 2. Okay, in numbers 8 and 9, we don't give you the endpoints, we give you the midpoint. So I'm going to deal with each coordinate one at a time. So if I had point B, I would say right now the coordinates of B are at x comma y. So what I'm going to do is I'm going to take 5 and x, 5 plus x, and remember if you divide by 2 then you get the x coordinate of the midpoint. So I'm going to set that equal to 6. So multiply both sides of this equation by 2, and you will get 5 plus x equals 12, and then minus 5. So x is 7. That is your x coordinate of B. Now your y coordinate. Take 12 plus y divided by 2 equals 15. Multiply both sides by 2. You get 12 plus y equals 30, and subtract 12 from both sides. So the coordinates of B are 7, 18. We'll do that one more time. This time we're given point B and the midpoint. So point A we're going to look for, and I'll call the coordinates of A, x, y to set up my algebra. Now if you want to, you could also use partitioning. Notice how I'm not using the partitioning right now because I'm making us practice the midpoint formula. But you are welcome to use partitioning if you see it that way, if you prefer it that way. Okay, so here's an endpoint. X coordinate is -2 plus x divided by 2 is -3. Multiply both sides by 2. X is -4. Now I'm going to look at the y coordinate. -16 plus y divided by 2 equals -13. Multiply both sides by 2, so I get -16 plus y equals -26. Add 16 to both sides, and you get -10. So the ordered pair for A is -4, -10.